So what is the need of MV Max? 802.11 does not perform well in mobile environment. We will talk about this, and we will talk about what is performance anomaly and how it affects 802.11 algorithm. What is actually MV Max? MV Max algorithm is the algorithm which we define about how network scheduling or a vehicular communication scheduling should be made so that it is effective and gives maximum throughput. So 802.11, the slower car slows down the faster one. So this is the scheme. This is car which is in near to access point, so it's in 54 Mbps range. Suppose a car is coming at a behind it. So as you can visualize, this access point is near to this car, and suppose there are a lot of car coming in. So this car and this car are both coming at simultaneously, but they're far apart. Firstly, this car is close. Later on, this car will come near. So what is happening over here is this is a 54 Mbps connection, but this is suppose a 1 Mbps connection. So this 1 Mbps guy pulls down a connection speed of this guy, which actually means if there are a lot of car coming in this highway continuously, then all the cars which will be coming, whether it is this guy or this guy, will all get a very low throughput. There will be a consistent low throughput, and every car will get a very low amount of data transfer, which will be very unacceptable amount of data which we can transfer. As you can see, I'm sending slow, and the car behind me will not allow me to send at full rate. Cooperation is not always good. That is the basic idea about this slide, you can say. So you should not cooperate all the time. They are cooperating, and because of which they are losing a lot of data. This is analogy of MV Max, which we are talking about, that let's wait for a turn. Instead of cooperation, we will cooperate in different manner. Let's wait for our turn. This is what is happening. That was 54 Mbps connection. Now this is sending at maximum rate. What we are doing is, when this car is closest or when the signal strength is highest, I will ask this car to send data, and I won't send any data to this car. So here is the idea. We won't allow any car, how many they are, we don't care. We only allow one car at a time to send the data, and that car will be the car which has a maximum data rate. We will prove by results, and I will further explain how this scheme will benefit all the cars. This is an unfair algorithm but gives maximum throughput because of three phases which I will talk about: initial phase, production phase, and the exit phase. But let's talk about right now. I will be able to send at high rate soon. It is not sending any data right now. This car is not sending any data, and this is the only car sending data, and it will be able to soon when it comes in the range of AP. One by one they will get their turn. So this is the setup, and by the way, this is me. Okay, so I am testing this algorithm over there, and I will talk more about this. This is the car which has the antenna on the top of it, and this is my partner David, who is walking around the street to check the algorithm which we made, the bitrate algorithm. I'll talk about that too. This was the test which we are testing, our MV Max algorithm. The car was moving on the side of the road, and by the way, there is an access point situated. This is a view from the car, and I'm testing the bitrate algorithm. So actually what happens is, in a vehicular communication, there is a phased distribution. As you can see, when the car is closest to the access point, At that time it has a capacity of sending data at 54 Mbps. That means per second they can transfer a maximum of data of 33 Mbps. That actually means a lot of data can be transferred in the time, which is when it is close to car. And if some other guy does not pull down his speed, it can really utilize all that data, all that phase in which it has a maximum data rate speed, and next car will get a stone. So there are three phases. The first phase in which the car is entering, the entry phase. This entry phase shows amount of data transferred, which is of course very low because of the low data rate. This is the production phase in which it starts producing data when it's closer to access point. And this actually phase distribution is about single car moving across the road. Suppose there is no other car or one car, then if there is only one car, what will happen is entry phase will have some data, production phase will have much more data, and the exit phase will have a very low amount of data. So these are three different phases of the car. So if we eliminate this phase and this phase from a car, then effectively total amount of data transferred will not be significantly affected. In fact, if every car utilizes their production phase to the fullest, then they have virtually utilized their all the phases, and this entry phase and this exit phase is much longer in terms of kilometers than this production phase. So basically this production phase is of 54 Mbps, and these entry phases are from 1 Mbps to 24 Mbps, and these are again from 1 Mbps to 24 Mbps. And this is the maximum amount production phase, which is the shortest but which produces much more. So this is a very dynamically changing environment. So this was the work done at Waterloo, and this is a slide from David Hedaler, who presented our paper in Mobisis. So goal: make full use of production phase, reduce delays in connection setup, avoid the fringe. Avoid the fringe actually means avoiding this phrase, entry phase and exit phase, and use more suitable bitrate selection algorithm. I will talk about that. And future protocol design, environmental awareness, I will talk about that too. So what are other problems? This was one problem, and we discussed about a single solution about it, that we can provide a phased distribution in which the data will be transferred only at that stage which will be productive, or which will be of course very short. There are other problems also, like as you can see, even in the production phase there can be problem like very late start, and then exit before a production phase. So what it means is, in production phase also it can happen that a car starts transferring data at this stage and stops transferring data at this stage, because either it is not able to connect or it is not able to transfer data. What are the problems of that? So first of all, I will talk about what are the problems of problems because of which there is a late start. The problems because of which there is a late start can be attributed to, for example, you are aware of TCP algorithm, right? So at Wi-Fi layer, there is a first data transferred at TCP layer, and there is a SYN request sent to the access point for the connection establishment. Now suppose that SYN request is lost, and the timeout for the SYN is 2 minutes. Before another SYN request is made, the car is traveling at a high speed. it will come slow close to the access point that before another SYN request is made by the TCP connection. The car will have almost passed the production phase. 2 minutes is a very long time in a vehicular communication model. If you are talking about a vehicular communication, then 2 minutes is definitely very long duration. It's definitely not long in 802.11 environment in enterprise setup, but it is a long duration. We have to make sure that the connection is established as soon as possible. uh, Another problem, there is a timeout. So car is moving at a very high rate, so signal strength is reducing drastically and changing drastically, and because of this dynamic scenario there will be of course more losses. uh, and if there are more losses, if there is a one loss of a data, of a packet, then before the timeout occurs, the car passes away the access point and the production phase is again lost. So we have to again avoid that.